And it's recording. All right. So, exercise 2D, 2 skills that you need to be able to do. Skill number 1, you need to be able to identify the different shapes of the 4-sided shape. So, quadrilateral, you need to be able to tell the 7 different shapes there are for quadrilaterals. So, quadrilaterals fall under a topic which I want you to fill in. It is called, oops, I'll do it in black actually. Polygons. Hands up if you know what a polygon is. Arman?
Isn't it like a 2-sided shape? It's not a 2D shape.
It is a 2D shape, but I mean, circle is not a polygon. What is the definition of a polygon? Anyone know? No? Okay. Polygon is a any-sided shape, but the sides have to be straight, specifically. Okay, so some of the polygons that you might be familiar with is like pentagon, hexagon, octagon, nonagon. What's 10? Do anyone remember 10? Decagon, very good. And then 11? Undecagon. And then 12? Dodecagon. Okay, so what about 7? I skipped 7 before. Anyone know? After hexagon it is? No, pentagon is 5. Nona is 9. We can make up a new one. But that's for the next exercise. So those are polygons. Now, we can't have a 2-sided shape because if you do 2, you get an angle. Okay, that's called an angle there. So the minimum that you can have that encloses it and makes it a shape, or 2D shape, is 3, which is we call a triangle. That was exercise 2C. Then you move on to 2D, where you then now do 1, 2, 3, 4. So there are 4 sides, so hence why we call it quadrilaterals. Now, there are 7 different shapes that you must be able to identify. So let's start, and I drew this flow chart to help you identify them. Let's go on the very left. The very left, the first key identifier is that this shape is the only one that has no pairs of parallel lines. What do we call this shape normally? Hands up, there's 2 names for it. Lossalia? We can have a kite, and then sometimes other people call it a, starting with D? Diamond. So kite or diamond, they're very specific in the sense that they do not have any pairs of parallel lines. It's 4-sided, but it has no pairs of parallel lines. So nothing is actually in parallel. Number 2, there's also some key features that helps you solve these problems because the sides, have you noticed the sides, the opposite sides do not equal. See this length here that I'm coloring in, yellow, and this side, they don't equal. So opposite sides don't equal, whereas a rectangle, which is what you're more familiar with, opposite sides do equal. See, these opposite sides are equal. Kite is the only one where opposite sides do not equal. But instead, adjacent sides are equal. So I'll spell out what I just said. Adjacent sides are equal. Adjacent, for those who do not know what that means, it just means next to. So the 2 lines that are right next to each other, they're equal. So you got 2 pairs of adjacent sides, which conveniently makes it symmetrical. Because if I cut this now in half directly down, like this, if I cut it down directly, you get 2 sides of the shape that are exactly the same because this side is equal to that side, and then the yellow side is also equal to the yellow side. You get a symmetrical look. So not only do the sides equal, that also implies opposite angles here are equal. These 2 are equal. Okay, so that angle and this angle, they have to be symmetrical, so therefore they must be the same as well. That's one of the key properties that allows you to solve when you see a kite. Why am I telling you these properties? Because students usually don't read the properties. They don't look at the notations. They use their intuition. And this is what happens in the test. I will give them something like this. Whoops, let me just do it again. And then I tell them to find, I don't know, this, one of the angles. And they will get this wrong because they make an assumption. First thing is I drew it in a way that, and I would normally say it's not drawn to scale. So when I draw this, most students think diamond straight away because it kind of looks like a diamond, especially when I draw it that way. Yeah. But the sides, have you noticed I put these dashes? What do these dashes mean? All the sides are equal. And didn't we just say in a kite, opposite sides do not equal? So it can't be a kite. And the reality is that it could be just slightly longer, even though it doesn't look it, I could make it slightly longer. It could be 0.01 centimeters longer, but you can't tell that just looking at the diagram. So hence you have to look at the notation. This is not a kite. Instead, if all sides are the same and the angles do not equal to 90 degrees, anyone know the name of this shape? No, square has to be 90 degrees, so all sides are the same, and they have to be 90 degrees. Rectangle does not have all sides the same. They have two sides that are different. So which one of your quadrilaterals anyone knows starting with R? Rhombus. Rhombus is like a square, but doesn't have 90 degrees. So where does that belong? It belongs all the way over here. So over here, this is the one that students confuse with a diamond, especially if I flip it around and make it look vertical. Most students say diamond or a kite. This is a rhombus. Rhombus has all or four equal sides. Very similar to a square. See, a square has all four sides the same, but they also have a 90-degree angle as well. So they all have to have 90 degrees. So 4 equal sides and 4 equal angles. That's what makes a square and a rectangle special, and that's one of the easiest ones to learn when you're in primary school. Yeah? All right, so this one's a rectangle. Now, rhombus, rectangle, square, they all share a familiar thing. Does anyone notice what's familiar? I mean, rhombus is similar to a square because they have 4 sides the same. Rectangle is similar to a square because they have 90 degrees. But what do they all share? And it's the reason why I clumped them all on the right-hand side. What do they all share?
Do they have 4 sides?
Well, all of them have 4 sides. A kite has a 4 side as well, but I didn't group them together. What else? Rira? Not sure. Think about why I clumped it on the right. So why did I clump the kite on the left and I said no parallel lines? And what about these 3? Yep. Not all angles are equal. Only a rectangle and a square have all angles equal. This one actually, angles are different. But I can see why you were thinking that. Because one's acute and one's obtuse. So it can't be the same. Yeah. They're the only ones with 2 pairs of parallel lines. So if you have a look here, this one is 1 pair. Those 2 are running in the same direction. These 2 are running in the same direction. That's 2 pairs of parallel lines. Same thing with a square. A square also has 1 pair. So here's 1 pair. They're both going up and they're both going to a side. But it's not all the same direction. So 2 pairs of parallel lines. Same thing with a rhombus. Notice the arrows. These 2 are going the same direction. That's 1 pair. And these 2 are also going the same direction. That's another pair. So these 3 all have in common that they both have, or all 3 have 2 pairs of parallel lines. So here, under 2 pairs of parallel lines, this one is not a rhombus, not a rectangle, not a square, but starts with P. Anyone know? What? Parallelogram. And for those who don't know how to spell it, spell parallel first. So that's how you spell parallel. And then ogram. Parallelogram. Okay, so parallel and then ogram. So parallelogram, 2 pairs of parallel lines. That's what's similar. So I think of parallelogram similar to rectangle, no 90 degrees. And I think of a rhombus similar to a square, but no 90 degrees. That's how I remember the 2. Yeah? So if you look on the very left, it says no pairs of parallel lines. There's only 1 shape. It's a kite. if you look at two pairs of parallel lines, you've got 4 over there. And then trapezium is the only one with exactly 1 pair of parallel lines. That's how you can tell if it's a trapezium. Now I've drawn the 2 shapes that you might see as a trapezium. See how it only has 1 pair? See that? This direction, that's 1 pair. And then here we go, this direction and this direction. That's 1 pair, they don't have 2. So as soon as you see 2, it can't be a trapezium. And it also can't be a kite. As soon as you see 1, it can't be anything else but a trapezium. Okay, so that's the definition of a trapezium. 1 pair of parallel lines. Kite has no pairs of parallel lines. And then parallelograms must have 2 pairs. So those 4 have 2 pairs. So if you count them all right now, that's 1, 2, 3, 4, 5, 6. But I told you before that you had to know 7. Anyone remember what the 7th one is? So that's your 6 main shapes. What's the 7th one? Starts with I. R. What was that? Irregular shapes. Irregular. Why? Because you can draw a 4-sided shape that doesn't match any of those. So I can draw one that looks like this. Let me do it again. And maybe I'll make it more obvious. There we go. No parallel lines, but it's definitely not a kite. And so there's no parallel lines there. So it should be a kite. But a kite says that it has to have 2 sides the same and none of the sides are the same. That shape there is still a quadrilateral, but we call that an irregular quadrilateral. Okay, so those are the 7 that you must know, and I've put it in a flowchart to help you organize your information to remember. So if you flip over the page, the numbers are wrong here. That should be 4, 5, 6. Those are your 6 typical ones, and then anything that doesn't fit in those 6 is irregular. Cool. Now, in a 4-sided shape, so say like this one that I just made up, all the angles inside it must add up to what? Hands up if you know. What do all 4 corners inside must add up to, Amon? 360 degrees. Fill that in. And the logic behind it is if you just pick a corner to a corner, so I start off with this corner, and I cut it this direction, you end up with 2 triangles. So if I wanted to know this blue section, that angle there, plus this angle, we know that all the angles in a triangle must add up to 180. So this tells you 180 for the corners. But then if I add the remaining corners, this blue bit, that blue bit, and this blue bit, it also is meant to add up to 180. And so when you add 2 triangles together, 180 plus 180, that's how you get 360. So that means you can actually use this pattern and go on to pentagons, to hexagons, and you can work out how much all the angles should add up to. Here's an example. Let's do a pentagon. Pentagon has 5 sides, so 1, 2, 3, 4, 5. Now if you think about it, let's work out how many triangles you're going to get. Let's pick a corner. I pick this corner. And then I draw it to the next corner. Here we go. I got 1 triangle. Then from that corner, I pick another corner. How many triangles do I have? 3. So if I wanted to know what do all the corners add up to, you see, if I add all the corners together, it's really just adding all the angles of a triangle. But you got 3 of them. So that means it should be 180 plus the 180 over here, and then plus another 180. What's 180 plus 180 plus 180? 540. Okay. So that's how you would know for a pentagon, and you can do the same for a hexagon. You can do the same for a heptagon. It continues on. Yeah. But today's lesson, you're only working with 4-sided shapes. So hence it only adds up to 360. Cool. So that's the only theory. So what did you need to know? First one was identify. Can you identify all 7 shapes? And the second skill is, can you use the 360 to solve? So 2 skills. One is identify. Number 2 is to solve. Here we go. Let's do the first two problems together. Here we go. So, just looking at the properties of this shape, most students will get it just through intuition, but I want a reasoning. What shape is A? Hands up if you know. William. It's a kite. But I want to know why it is definitely a kite. Someone give me a proper reasoning. What hints have I given in this diagram to make sure it's definitely a kite? Yes, Will, again. Good. No parallel lines and then two equal angles. This was the key. That tells me there's a symmetry. And if it's a symmetry, that means these two sides must be the same. That was the hint that I gave out. Because you cannot draw these two lines and have the same angle and touching each other without them being equal. So as soon as you have 100 and 100, these two sides must be the same, and these two sides must be the same as well. Okay? All right, here we go. So now I've given to you, it's a kite, and we need to figure out the value of A. Now we know that this little box here is the same as, what is that angle there, Luke? When you see a box, that's the same as? Right angle, which is 90 degrees. Well done. So we got 100 plus 90 plus 100, and we need to know what A needs to be. So write out your working out. 90 plus 100 plus 100 plus A, we know it's meant to equal to 360, because that's a four-sided shape. Let's work it out. 100 plus 100 is 200. 200 plus 90 is 290. So how much more do I need for A to B in order to get 360? Aaron? 70. Very good. So therefore, A could equal to 360 minus 90, which is the leftover, 290. And that's how we then get 70 degrees for A. See how I'm doing it? Identify the shape. So draw the diagram, identify the shape, show me your method. How did you get to the answer? Okay, I need to see reasoning. Second one, B. What shape is B? Can I please have, let's go with Oliver. Do you know what shape B is? What is this one called? Not a rhombus. Rhombus has to have all four sides the same and doesn't have the dashes. So it's not a rhombus. Let's go with Elijah. Do you know what this shape is? Oh yes, you pronounced it wrong, but you got the right idea. It's a trapezium. So trapezium, what is the reasoning? How did Elijah know it's a trapezium? Aaron? Beautiful. When you only have one pair of parallel lines, that's how you know it's definitely a trapezium. So start off by asking, how many parallel lines do you see? Okay, so in this case, yes, it is a trapezium. Now, the nice thing about trapeziums, it links back to exercise 2b. Because if it has one pair of parallel lines, have you guys realized this is what you did in 2b? See, one pair of parallel lines? See this line over here? That line? That is your transversal line. That's what you've been practicing. So if I draw it in now, you see angle A is here and angle 70 is there. Can you see that? This transversal line, 70 is here, A is here. What are these two called again? A and 70 is considered co-interior. But if they're co-interior, they must add up to 180. Beautiful. So, if this is 70, A must be? What's A? If it's co-interior? 110, because it has to add up to 180. So, 180 minus 70 gives you 110 degrees. So if you understood your parallel properties, you could immediately answer A and say 70 and A is co-interior. So A has to be 110 degrees. And then you could use the same theory for 125 and B, because that's also co-interior. See, if I drew out this one, this is your now transversal line. Right there, this is 125 and this is B. They're both inside the parallel lines and they're both on the same side. So you can quickly work out what B is. What must B be if it's co-interior? Vera? 55, very good. Okay, so B is 55 degrees because it's co-interior. And therefore 180 minus 125 is equal to 55 degrees. Okay, so this is why learning what you learnt in exercise 2B can help you solve further problems. If you don't see it, it might be tricky to solve this one. All right, for the last two, I'm going to stop there. I'm going to leave you some time. I'm going to show you on the screen what the answer is, but I want you to have a go first. Okay, so I'm going to give you, it's currently 10:43. Let's give you 3 minutes to do the next two questions, and then I'll show you the answers up on screen. Okay, let's go. 3 minutes. I'm going to pause the video.